read recently online that somebody said Singapore has one of the best vending machines in the world. Did you all see the article? Vending machine. Apparently Singapore has vending machines for many different things. You know, typically when you think of vending machines, we think of machines that sell, what do they sell? Snacks? Okay, snacks. Snacks. So what do we put in? What is the input? What do we put into the machine? Are you putting coin? You put in money, right? Put in money. This is the input. Then what comes out? Okay, so you talk about snacks, right? So this is the output. So this over here is a snack machine. Besides a snack machine, how about in our school? What kind of vending machines do we have? We have drinks. Okay, drinks. So again, the input is again money. The output will be canned drinks. Output. So this is the drinks. And then at our movers and shakers gallery, we've got another vending machine. Do y'all buy from there? Why? Oh, okay, you're quite expensive at $2. So you put in money, $2, and orange juice. Out comes your orange juice. That's your output. We notice that all the inputs, they are the same, right? We always put in money, but the output is different. Here we got snacks, then we got canned drinks, then we got orange juice. Does the output depend on the input? In this very simple diagram that I've drawn, does it depend on the input? No, because the input is all money, right? So the same input, the same money, gives me different outputs of either snacks or canned drink or orange juice. So what determines the output? What determines what comes out? Since I'm putting money inside, same money inside all the machines, what determines what comes out? Logically, the machine determines what comes out, right? If I go to a snack machine, I cannot expect it to give me orange juice, isn't it? If I go to an orange juice machine, I cannot expect it to give me a canned drink, right? So inside this machine, something is happening. Inside the machine, it takes your money and it returns you something. Whether it is a snack, canned drink, or orange juice. So we need to understand what is happening inside here in order to determine our output. Okay, this is also known as a function. It's like a machine. You give it something, out comes something. Do you know that we've actually been dealing with functions already? It's a new term. A function is like a vending machine. You give it something, it gives you something as an output. Give you an example. Y equals to 2x plus 3. This is an equation, right? There are two variables over here. We've got x and y as the variable. Now my input, okay, my input is, as an example, input is x equals to 1. Can you tell me what the output is? What's the output? Output is, what is it? Y equals to 5. I put in x equals to 1. It tells me that, hey, since x is equal to 1, y must be equal to 5. That's the output. So this over here is like a vending machine. This is our input. This is our output. So for example, if the input is x equals to 0, can you tell me what's the output? If x is equal to 0, what's the output? 3. Y equals to 3. So this is one type of vending machine. I can have many different vending machines. For example, I can have a vending machine that is designed like this. Y equals to x minus 1. This is a different vending machine already. So if I put x equals to 1, I put in the same input. What is my output in this case? 0. Notice that the output are different. Although the input is the same, x equals to 1, x equals to 1, but the output is 5 here, the output is 0 over here. Why? Because I went to a different vending machine. So for the same x equals to 0, what is my output? The same x equals to 0, what is the output? 0 minus 1 is negative 1. Okay, so this topic we are actually learning about this type of vending machines, about input and output. I give you a value of x, you give me a value of y. I give you a value of y, you give me a value of x. Okay, so that is a relationship. Remember at the start of the year, I gave you many questions on the board, like 20 over questions here on algebra. Then I told you guys to choose the question you wanted to do, and you had to describe the location of the question. Remember that? So for example, if you wanted a question over here, you had to look at the number at the bottom. They tell me, oh, this is at column 3, for example. I want to do the question at row 5. So I'll look at, oh, column 3 is over here, row 5 over here. So this is the question you wanted to do. Remember, you did something like that? Have you played Battleship before? Does it work something like that? Okay, if you know how to play Battleship, you remember what we did over here? This Cartesian coordinate system is the same thing. Okay, we are trying always to find a position of something. A position on a flat area. All of you use, most of you use your smartphone for navigation, right? You want to go from one place to another place. Your Google Maps, for example. How does your Google Maps know where different locations are? You get what I'm trying to say? For example, if I have a map of Singapore, okay, very horribly drawn, and then Woodlands over here, in the north, right? Do you know where Tampines is? Okay, Sentosa, do you know where Sentosa is? In the south, right? Sentosa is somewhere over here. How do we describe these positions over here without drawing it? Geography, do you learn about coordinates? You did? Okay, that is the same thing. Your longitude, your latitude, they tell us where, along which line it is, and then you can pinpoint locations, right? That's the same idea for our mathematics coordinate system. In fact, it's just a little easier than what you have learned in your geography. Okay, since you know that already, I think I can start formally introducing you our Cartesian plane. Plane just means a flat area. Okay? So the position of a point could be a place. For example, Singapore, for example, Sentosa, Universal Studios. It is represented by an ordered pair. Ordered pair AB. Like in our geography, which one comes first, longitude or latitude? Did you all learn? I think the latitude comes first. I think only, I can't remember already. The latitude will come first, then followed by longitude. If I'm wrong, please let me know. But in mathematics, it is just a little easier. It is an ordered pair. We have to make sure we get the order correct. Okay, later on I'll explain what that means. So, A over here is a number. It's known as the x coordinate. Please copy this down. X coordinate. What do you think B is going to be? Yeah, exactly. Y coordinate. So notation over here just means, it means how we write. How do we write the position of a point P? So this point has a name. Instead of Sentosa, it is called P. We can either write it this way, P, open bracket, the x coordinate, comma the y coordinate. Or we can write P with an x coordinate, y coordinate. Later we will understand more about what this means when we put in some actual numbers. Okay, but these are the two ways we can write it. With or without the equal, they is fine. Okay, so make a decision. You want to write equal or not? If you want to write equal, then just write equal. If you want to write equal, don't write equal. Okay? Basically, your x and y coordinate, they are like address. It is like an address to a place. Now, x coordinate is a units horizontally from the origin. Okay, let's use an example over here. But we need to know what an origin is first. So, the origin is here. You see a number line? We have a horizontal number line. This is known as our x-axis. This is known as our y-axis. So we've got a horizontal line and a vertical line. They intersect at 0. 0, 0 over here. This is known as the origin. Okay, can you please write it down first? Okay. Now here we have an example. Point B. Point B has an address of 4, 5. Okay, so the coordinates is like an address telling us where exactly it is. So point B, 4, 5. It is 4 units to the right. This is a number line. This is a normal number line. 1, 2, 3, 4, 5, 6. On the other side, if you go the other direction, we -1, -2, -3. No difference from the number line we learned. From the origin, we always must start from the origin. We want to get to the point B. Unfortunately, we can't just go diagonally this way. We have to move in a horizontal and a vertical direction. So the first thing we are moving will be to the right. 4 units to the right. So please copy that now. 4 units to the right. That is where this number 4 came from. 4 units to the right. After 4 units to the right, we are going to take the lift. Let's take the lift up. 1, 2, 3, 4, 5. We move 5 units up. That's where the 5 comes from. Okay? Anybody wants to clarify anything? Alright, now let's go back to some of these terms. So the x coordinate is a units horizontally from the origin, and we said that the origin is from here, where the vertical and the horizontal line, where they meet, this is the origin. So this value 4 means it is 4 units to the right of the origin, and then B over here will represent 5 units from the origin. So we mark our cross and label. So here it was already printed for you, cross and a letter B. So this notation over here, this way of writing, they did not write the equal sign. They just wrote B open bracket. Oh, I skipped a page. Oops. Okay, never mind. I'll go back to the first page in a while. So here we have the cross for point B, and the origin over here, since it is 0 units to the right, then it must start with a 0. Can you guess what the second number is? Also 0. Okay, so this is known as the origin. It also has another name called the reference point, which we hardly use it. Okay, so my mistake. Let's head back to this basics over here. What time does our lesson end? Okay. Okay, so we have got a Cartesian plane intersection of 2 perpendicular number lines. So the 2 number lines I mentioned, the horizontal and the vertical. So the horizontal number line is called the x-axis, our standard number line. Towards the right is positive, towards the left is negative. this is our horizontal axis. So we call this the x-axis. And the vertical line is called the y-axis. So you notice in both the vertical and horizontal axis, we've got a little arrow either pointing up or pointing to the right. These two arrowheads must be drawn. Pointing up and pointing to the right. And you must label vertical for y, horizontal for x. The point of intersection of the two lines is the, what we said, what is it called? Origin, yes. O-R-I-G-I-N, denoted by the letter O over here. So this is the origin. Yes, it looks like a zero. You can treat it as a zero. It makes sense to treat it as a zero also. The Cartesian plane has 4 quadrants. So imagine like if this is a big circle. Imagine only this is a big circle, we divide this into 4 parts, right? So we got 4 quarters. What would you like to choose to name as quadrant number 1? Do you want this to be quadrant number 1, or this to be quadrant number 1, or this or this? We see there are 4, right? But do you get to decide? Unfortunately, you don't. Somebody has already decided. This is first quadrant. Okay, the one at the origin is I just saw the arrow here. This is the origin. Sorry, my bad. So this portion over here is the first quadrant. Logically, where will the second quadrant be? Top left or bottom right? Bottom right. That's what you prefer, right? Unfortunately, some guy chose this to be the second quadrant now. Okay, so we go anti-clockwise. So where do you think the third quadrant is? Bottom left. Third quadrant. And the final one must be the fourth quadrant. Okay, the circle actually doesn't exist. It is just to show you why they call it a quadrant. It's like a quarter. Okay, so far? These are some keywords that you need to know. So we have actually covered this page over here already. Can you tell me can you identify where is the point described by this address? 5, 4. Where is this? 5 units to the right. Okay, let me use another color. 5 units to the right. Okay, that's over here. And 4 units up. 1, 2, 3, 4. This is the point. This is 5, 4. So you compare 5, 4 and 4, 5. Are they the same? No, they are not the same. So our answer for this is no. Okay, I'll pause over here first. You know, I tell some of my other students, right, I like to use the idea of address for the coordinates. Because address tells us where somebody stays. Coordinates, they have the same function. They tell us where the point is. If I ask you, what is your address? What will you tell me? I stay at block 120, for example. I stay at block 120, maybe level 5. Something like this, right? Is this your complete address? No, I'm sure there's more. You need to tell me which unit. But in mathematics, we only need 2 pieces of information. We need only the x coordinate and the y coordinate. If I were to draw similarities, the x coordinate, the first number, it is at block 4. Point B is at block 4. What level is it on? Level 5. Okay. I will now show you why it is quite useful to think of it as blocks and levels. When you want to go to your friend's house, your friend tells you, I stay at level 5. Versus he tells you, I stay at block 120. Both of them are incomplete, right? But does one answer narrow it down significantly? Which one is more important? The block is more important, because all over Singapore, there are only a handful of the block, same block number. But there are so many level 5s all around. So the more important one is the block. We need to know where this person stays first. Which block? Once they tell you the block, then the level is the next more important part, isn't it? So this is why you need to remember. Block first, then the level. Okay? And it's common sense now. Block followed by level. Block, then level. Block, then level. Okay, look outside the window now. Look at the blocks. And look at the levels. Are the blocks vertical or are the levels vertical? Imagine a very tall HDB flat. A block 120, for example. Is the block standing upright or is the block lying down on the floor? It is upright. Okay, so blocks are vertical lines. That's what I need to remember. Blocks are vertical lines. What about levels? Levels are horizontal, isn't it? Okay, so that's one thing that can help us remember. I will come back to this example for point B. Again, the block has to come first. This is the block. What block is it? Our point B, it is at block 4. Blocks are vertical, so take a ruler or something that is vertical. This is my block 4. Okay, this is block 4. And we see the same number 4 at the bottom over here. So imagine if you're a person walking, looking for your friend. He says, I stay at block 4. Then you see, oh, this is block 1. This is block 2. Block 3. And block 4. Okay, I know my friend stays here. He says he stays at block 4. Then I need to ask him, hey, what level do you stay? And he says, I stay at level 5. So you take the lift up. Level 1, level 2, level 3, level 4, level 5. This is his address. This is level 5. I hope this analogy is useful to you as you start out, because many students forget, oh, what comes first? Is it this number at the bottom comes first, or does this number come first? Is this point B read as 4-5 or 5-4? So they get confused. So what I want you to remember is the block comes first. The vertical, take something vertical and look at where it intersects. So it intersects at 4. So the first number must be 4. Block first. Okay? But of course in mathematics, we are not going to ask you, hey, what block does this person stay at? We're going to ask you, what is the x value? So you need to know that instead of calling it a block, we call it x. Instead of calling it the level, we call it y. Is it difficult to remember that x comes before y? No. Okay, done. You have memorized everything already. So now, write down the coordinates for point A, and I will demonstrate. A is found here. I need to know what block this guy stays in. This is, so blocks are vertical. Look out the window, blocks are vertical. Okay, so take something vertical. This is block 1. This is block 2. A, my friend A stays at block 3. Okay, so 3, comma. So 3, comma over here. You must have the brackets. The brackets are necessary. You cannot choose to leave it out. Must have. Comma also must have. So A is block 3. Then we need to take the lift up. Level 1, 2, 3, 4, 5. Level 5. So 3, comma 5. Okay? So again, in mathematics, they're not going to ask you about block and level. They're going to ask you what is the x value. But then you must remember, oh, the x value is the first one. X comes before y. So the x coordinate of A is 3. is 5. Now your turn. Write down the coordinates of point C. Coordinates of point C. We've got 5. Block 5, level, wow, quite hard to see. It is 2 small squares. Can you see it is 2 small squares? Okay, so if one big square, or rather 5 small squares is 1 unit, then how much is 2 little squares? 0.4. Okay, so this will be 5, 2.4. This guy stays at level 2.4. He's stuck between level 2 and level 3. So question, is A equal to C? Obviously not. No. Why? They have different x and y coordinates. They have different x and y coordinates. Now we come to the notation. Can we write b equals to 6, 1? So this 6 over here, what does it refer to? Block or level? Refers to block. It refers to the x value. So you compare, oh, x equals to 6. Makes sense, right? The number 1 over here, what does it refer to? The level, otherwise known as the y value, x and y. So the y value is 1. Yeah. Yes, we can. We can have the equal sign in the middle. Question G. Can we write b 6, 1 without the equal sign? Yes, we can. These are the 2 ways of representing it. Can we write b equals to 6, 1 without brackets? Cannot. Simple enough? Exercise 2. Part A. What is the y coordinate of all the points on the x-axis? Where is the x-axis? Here. The horizontal line shown is our x-axis. What is the y coordinate? So y, every time you see the y, you think of it as level. Right? X is the block, y is the level. So what is the level of all the points on the x-axis? So they give you many examples. All these crosses on the x-axis, they represent points. What do you notice about all the y coordinates? X, y. What is the y coordinate here? 0. Okay, and the next point, x, y. What is the y coordinate again? 0, 0. Do you notice that the y coordinate of all the points on the x-axis is actually 0? Does that surprise you? It shouldn't, because y coordinate represents the level on the x-axis. You're on the bottom already. You're on the ground level. In Singapore, we call the ground level level 1 lah, right? Then you go up 1 level, it becomes level 2. But in our mathematics over here, the ground level is level 0. Okay, so this horizontal x-axis represents all the y values to be 0, including points over here, including points between 2 integers. For example, over here, all these points they are all at level 0. All their y values will be 0. So the next question for part B, what is the x coordinate of all the points on the y-axis? On the y-axis, so we identify this is our y-axis. The x coordinates, so the x will be the block. What is this block? What block is this? Oh, I know that it is block 3. This is block 2. This is block 1. This must be block 0. Then this must be block -1, block -2, block -3. Okay, so this is actually block 0. Blocks are x values. The block comes first, the x comes first. So instead of writing block equals to 0, we write the x equals to 0. Okay, now exercise 3. Finally, we get to try using what we have learned. State the coordinates of P and of Q. Let's start with P. We need the address of point P. So we need a block first. What block does it stay at? Yeah, it stays at block 3. Because blocks are vertical. Take something vertical, put it down, and it cuts 3. Then what level does it stay on? 1. So read this as 3, 1. X equals to 3, Y equals to 1. Do the same for Q. What block does Q stay at? Negative 2. What level does it stay at? Yeah, poor thing, it stays in the basement. Okay, so now we can move on to part B. State the quadrants. Which quadrant does P lie in? What quadrant is this? Quadrant 1. Then this is quadrant 2, then this is in quadrant 3. So part B done. Now we move on to part C. I will demonstrate how we plot R. Then you do the rest. Okay, so the point R is at block 1. In other words, x equals to 1. So I need to find block 1. Block 1 is over here. Level 3. So take the lift up, level 1, level 2, level 3. This is my position for R. And I draw some dotted lines to indicate this is where he stays. Put on the coordinates 1, 3. So this is what we have for question C. Do you think you can do the rest? S, T, U, V, W, X? Okay, please try. Okay, check your work. If everything is okay, move on to exercise 4. Write down the coordinates of the points A to J in the diagram itself. So for point A, write down open bracket, write down the x value, comma, y value, close bracket. So that's for A to J. I'll show you for exercise 4, the coordinates for A. The x value or the block number is 3, level or the y value is 0. So this is the first answer. So these are the answers for exercise 4. Then for part B, to answer part B, which points are in the first quadrant? So the first quadrant over here, that's where we have the positive x and the positive y. The points in the first quadrant will be B and C. What about A? Is A considered in the first quadrant? If you consider A to be in the first quadrant, then can I also say that A also lies in the fourth quadrant? You see the problem? We cannot say that A lies in the first and the fourth at the same time. So A, it actually lies on the x-axis. It is neither in the first nor the second quadrant, nor the third nor the fourth. So part C, which points are in the fourth quadrant? So we have I and J. Which points on the y-axis? On the vertical axis, we've got points D and H. On the x-axis, we have just A. -2, 0, -3. You get the idea? Please finish it. Okay, so actually we're just copying around the numbers. The first number will be the x value. Okay, so that's it for the questions that we have over here. Then you look at exercise 6, graph paper. Do you have graph paper? Is it in your book list? Okay, you should have it. So try by yourself, graph paper, plot the points S and T using a scale. This is important. A scale of 2 cm to represent 1 unit on the horizontal axis. So on your horizontal axis, every 2 cm on your graph paper will be 1 unit. And they've got another scale, 1 cm to represent 2 units on the vertical axis. Then join the 2 points, find the area of SOT.